Welcome to today's presentation, Secure Your Cloud Estate with Continuous Audits, using Chef Inspect for Cloud Security. Let's go ahead and get started. Alan, over to you.
Thanks, Erin. Great pleasure to meet you, everyone. This is a series of webinars that we're doing on a monthly cadence, so hopefully you've had an opportunity to listen to us present on other topics, but it's going to be a rotating subject matter, so hopefully we'll be able to see you and engage with you in future webinars as well. There will be more information on the upcoming webinars later on in the program. So we're going to be talking to you about securing your cloud estate or farm with an approach that we call continuous audits. It's essentially using Chef effortless infrastructure with Chef Inspect for your ultimately leveraging your cloud security. So before we go any deep into the program, I want to kind of cover some of the kind of industry trends and some of the state of affairs, if you may, for cyber crime. For instance, in a fairly recent study in 2017 and 18 done by the CSO Magazine, there were a few interesting findings from these surveys, and that cyber threats continue to be top of mind of most enterprises and small and medium businesses. Excuse me. 64% of surveyed report that they were most concerned about cybersecurity threats in 2018 than they were in 2017. So it's a growing concern in most organizations today. Security budgets continue to rise. 59% of organizations said that their security budget had increased in the past year. And on average, the annual budget for IT security alone was around $15 million in the same year in 2018. 74% of organizations prioritize best practices, while 69% prioritize compliance efforts in their security spendings. 46% of these organizations hope to deal with these external attacks by adding new technologies, while only 34% will implement audits and assessments to curtail these attacks. All of these compliance and governance efforts keep about 34% of surveyed away from more strategic and important aspects. They keep them on a tactical security approach than more on strategic efforts. And we're going to start with a quick poll survey question, and it revolves around how your organization does compliance audits, or how often does it? Is that on a quarterly basis, on a yearly basis, or less frequently, or never, rarely, or never in terms of your supply? If you would kindly submit your questions so we could see the results as they're coming in. Okay, we see that about quarterly or less frequently as well. So quite interesting finding. So it's not a reoccurring aspect. It's definitely not in the continuous approach that is best recommended for security compliance. So why is that? Why are audits and compliance so painful? We really take an approach that we look at compliance or periodic audits to not really tell the whole story. The assumption is that these point in time when these audits are done, that people assume that the level of compliance and security is maintained at that level. But in reality, the actual compliance level actually fluctuates in between those point in time. So periodic audits really leave organization open, windows open for risk. Essentially those troughs or those valleys where the security compliance is not done continuously is really a concern and a factor of of grave concern for maintaining that security level at the highest level possible. So for the next poll question we have is, at what point do you evaluate or scan your environments for compliance? In terms of the SDLC, is it in a QA process? Is it in pre-production? Is it right before the production drop in? Is it actually in production? Or do you do it continuously throughout the development life cycle? So kind of, if you answer those, we could see the results as they're coming in. So Nick, what do you see in terms of out there as the responses are coming in? What do you see out in the field in terms of where these evaluations are typically done?
It really does run the gamut. And I think like what's key to the sort of assumption of maintaining audit readiness that proves to be false is just by virtue of how often are changes happening, and do those changes correspond with any validations? Because essentially, as soon as anything in an environment changes that doesn't have an associated audit action, you no longer know your security posture. And it's something, as we dive into migrating workloads into the cloud, it becomes exacerbated just because I think at that point, organizations also have less visibility into what things they even need to track, since a lot of the technology has changed and auditing practices that may have served them on-prem need to be reevaluated for their new cloud estate. And
cool.
So, yeah.
So as you're seeing that, where do we go with kind of what's the typical compliance kind of direction, and when it's done? It seems that a lot of them, about a third of people are doing it before production, and several are doing it continuously. So that's a great thing. So,
and that's ultimately. What's that?
I'll hand it over to you, and you can take it from there.
No sweat. Yeah. And ultimately, that is the direction we have been trying to guide folks into going. And in a lot of ways becomes really a prerequisite to being able to authoritatively assess your compliance or security status within a cloud estate. Because everything that is true across all environments becomes doubly true in those cloud environments. But before we get there, let's talk about why it is we want to do things these ways. And ultimately, when traditional approaches save that security review until after QA, pre-prod, as a go-to production milestone, we have a lot of problems that this creates for us. Ultimately, a lot of these processes are very manual and slow, and that's why we wait to do them until the end of that process, because the time cost means that if we moved it any earlier, we'd have a hard time pushing any change through. Of course, it creates a new bottleneck for us at the end of this process, because ultimately what you have in this state are teams that are working on different desired states. You have development and operations teams just making sure that they can deploy their applications and provision the environments for them. And ultimately, when it comes time for security review, you have security-focused teams that are using a completely different set of tools. And those tools often will create a lot of false positives. So another issue with this sort of saved review is you go and run a scanning utility, you get back a ton of data, and then have to spend some time parsing out which of that data is actually a valid concern that needs to be addressed, and how much of it is just sort of white noise that gets generated from all too general systems. We're still, by saving things to late in the game, we haven't actually defined what's correct up front a lot of the time. So essentially, if we're not validating our security posture early in development, then we don't necessarily have developers that are designing things with that security in mind, because they don't have any way to sort of test against whatever standards an organization is beholden to. And ultimately what that means for us is that we wait until very late in the development cycle to uncover things that might impact when we're able to go to market, when we're able to release new updates to our applications, or even when we're able to apply simple patches to deal with emergent vulnerabilities. And above and beyond all of this, the reality is that a lot of organizations aren't able to meet the strictest compliance standards of the frameworks that they operate under. A good example of this is that we have worked with a manufacturer that uses a piece of legacy software that only runs on an older version of Windows. And of course, the maintainer of that software has long since gone out of business. And therefore, we find ourselves in a situation where we need to run some systems that might not fulfill our standard compliance requirements, and we address those by creating compensating controls, essentially attacking it from a defense in-depth perspective, adding firewall rules and added security. The problem is when we're using these fairly cookie-cutter tools, every time we're auditing, we have to account for those exceptions and go through with our auditors why it's okay that we're running these things on outdated platforms because we're doing X, Y, Z extra. So we don't have a good way in traditional tools to acknowledge a compliance failure, but also mark it as okay because we have taken additional security measures to compensate. So ultimately, the crux of this problem from Chef's perspective is that you have different teams speaking very different languages, and ultimately losing sight of the fact that each of them is working towards the same business goal. So from a compliance officer's perspective, we need to adhere to these compliance policies, because if not, we're going to be subject to fines. We're going to be subject to lots of work that is required to get us back in business. Our security teams have similar sets of perspectives, but are often having a much more granular and specific focus on things like emergent security vulnerabilities and the like. Whereas our development and operations teams are worried first and foremost about making sure their systems work as expected, and often have to spend a lot of time translating from those compliance requirements to the actual activity they'll need to take to fulfill them. And a lot of time gets spent in that translation that's ultimately wasted and slowing us down. So where does Chef's perspective come in? We evangelize managing our compliance as code as a way to achieve continuous compliance. What stops you from evaluating your compliance early in the process is that if we have to spend time translating manual processes into each team's purview, we're going to be not building the things our organization needs to get us and our customers what they need. So ultimately, by defining compliance as code, we're first and foremost able to scale more readily. We can avoid complexity sprawl, and as we have new systems and targets that need to be evaluated, they can be evaluated in much the same way. This becomes ever the more important as we have organizations growing their cloud footprints and need to make sure that they apply the same rigor to their cloud environments that they've historically applied to their on-premises estate. Again, the goal here is to shift things left. And what that means is always be evaluating compliance as early in the development lifecycle as possible. If we're able to identify possible security or compliance concerns early in our development stages, we're able to address those without finding them late in the game and engaging in what is often very costly rework. Our continuous visibility is also key. By defining things as code, we can also formalize the output of running that code. And in Chef's case, we have the ability to collect and aggregate compliance and audit data in our Chef Automate dashboards so that we have visibility into how things are currently configured, as well as how they've changed over time. And finally, by managing compliance as code, we're able to better collaborate. By drawing a direct line between the compliance standards that we need to adhere to the actual work that needs to be done to remediate any problems. By defining our compliance as code, we've taken each compliance failure and turned it into an actionable insight so that we can remediate whatever things we are not in compliance with in a programmatic fashion. And so ultimately taking this process and tying it back to the cloud, one of the things Alan and I did was pulled up a recent publication from CSO where they lay out the dirty dozen cloud security threats. And this actually comes from a Cloud Security Alliance, CSA, white paper, ebook. I'm not sure what the designation is, but they call it the Treacherous 12. So a couple of dueling supervillain team names for what are our top cloud concerns. But what we're looking at here is a list that is ranked by the severity as polled by security professionals across the industry. So I'm not going to go through all 12 of these in detail, but it's probably worth taking a look at least the first few of these and how they relate to some of the problems we're going to have to solve. It's probably no surprise that number one on this list is data breaches. For one thing, they're not specific to the cloud at all. And in fact, if we take a look at the example called out in the CSO article, they talk about a password database that had unsalted passwords stored within it, which is something that could compromise us as easily on premises as it does in the cloud. On top of that, we do have new areas of concern that are specific to cloud. You don't need to go far to see where sort of cloud services related to storing or managing data, things like storage buckets and database services, have been compromised due to insecure configuration. To that note, it's also no surprise that right up there with databases, with data breaches rather, is insufficient identity, credential, and access management, because this is critical to anything we need to do in the cloud. And we can actually see this if you take a look at the threats that follow. Almost all of them can be tied directly back to that access management problem. So if we take a look at item 3 here, insecure interfaces and APIs, right? Because cloud services are often designed to be managed over APIs so that our teams can automate the process of managing their cloud estate and might make use of third-party tools that also use those APIs, it's imperative to have an understanding of how data is flowing in and out of our environments and that our access policies are sufficient for us to safely use those services. Ultimately, if I have insecure IAM, even a securely defined API can be compromised because I have a security flaw higher up in my access chain. And of course, we can see the same kind of relationship with a lot of these things. Take a look at account hijacking, number 5, malicious insiders, number 6, abuse and nefarious use of cloud services, number 10. All of these are issues that can be partially or fully addressed by having a good policy around identity control, rotation of keys, multi-factor auth, the whole works. Another thing I found really interesting looking through this is right below those 3 is system vulnerabilities. And of all the things on this list, this is the item that seems to me least unique to the cloud. Whether we're running on-prem, in cloud environments, fully containerized systems, we can be impacted by a new CVE, which is common vulnerabilities and exposures. And so seeing how high this is on the list and that really there isn't anything in my mind specific to the cloud that makes this more of an issue, it really does speak to the universal nature of a need to address how we patch our systems and how we identify and remediate those CVEs as they come up. Because ultimately, again, whether we have on-prem servers, cloud VMs, Docker containers, or beyond, a system vulnerability can exist there. And we're only as secure as our ability to assess and address vulnerabilities across any of the platforms that we manage. Now, while it may be most clearly exposed via system vulnerabilities, a running through line in this list for me is that many, and in fact most of these threats are not unique to organizations that run workloads in cloud environments. What is unique to cloud platforms are a couple of new variables they bring to the equation. For one, we have the ability to provision and scale our environments far more quickly than was previously possible. Being able to do something as simple as spinning up and down dev environments on demand or auto-scaling out production gives me more flexibility to grow than I previously had But of course, the more I grow my environment, the more I need to make sure that every individual component is securely configured. And that's very difficult to do without an automated process for assessment. The second thing is that cloud services for storage and networking essentially are fundamentally new workflows for most organizations that are adopting cloud for the first time. And they need to be implemented securely, lest they become a new attack vector. So while I might have services that make managing things like data storage easier for me, it's also a new means of audit and remediation that I need to work into my team's workflows to ensure I'm using those tools safely. And ultimately, this can sort of be seen throughout, and we'll look at some specific examples and how they relate back to this list. But before I move on, I want to spend a moment taking a look at that security threat number 12, shared technology vulnerabilities. So ultimately, what's being captured here is that cloud services, tongue-tied, cloud services themselves are often created from other third-party tools, open source tools, off-the-shelf tools, and are maintained by humans just like you and I. And cloud providers have to figure out how they measure their security the same way that the rest of us do. And ultimately, what this means for us is that even though our cloud provider provides us with tools that we can securely configure, we still need to take that same defensive, in-depth approach to anything that we deploy, because we are not in control of those tools. So it's heartening to me that this is at the bottom of the list. It says to me that cloud providers are doing a good job of securing the services they provide. But it's often a reminder here that, again, just because you have something like a security group doesn't mean you don't also need to look at whether or not you want a firewall on individual systems, say. So with kind of the groundwork laid for what sort of threats are out there, probably the most important thing for an organization to be familiar with when migrating workloads into the cloud is the concept of the shared responsibility model, because this is exactly where people get into trouble. Ultimately, at a high level, and this is a diagram that comes from Amazon Web Services, you and your cloud provider share a lot of responsibility. What the cloud provider is responsible for is making sure that the cloud services they offer are themselves secure. So if you're going to use Amazon compute, storage, database, networking, you need to be able to rely on those being securely created. However, you as the customer of that cloud provider are responsible for security within that cloud system. So while Amazon can provide you with compute and storage, it's still on you to ensure that you're configuring those things securely. Because ultimately, we can create, say, storage buckets that are 100% public for things that we want to disseminate to the world, and other things are going to contain proprietary or private data that we want to make sure are not exposed to the world. So ultimately, these cloud-provided utilities are only as secure as we make them. And ultimately, understanding what is in use and what needs to be done to secure them is the gulf where organizations get in trouble. I bring out storage for a very good reason, because it's where you can see a lot of those data breaches that security specialists are worried about happening out in the real world. You have a cloud provider that makes a secure service like S3, but you're responsible for its configuration. In the past year, there have been dozens of enterprises that have had their data breached or lost due to improperly secured storage resources alone, to say nothing of databases, access control, etc. So it really speaks to the importance of getting this right, because it's very easy to have a lot of damage done from a very minor configuration deficit. So where does Chef come in this picture? Well, Chef provides what we call the Effortless Infrastructure Suite, which gives you everything you need to start auditing and remediating issues in your cloud estate. First, we have Chef Automate, which provides a consolidated and filterable dashboard to drive observability. You always need to know what state your environments are in, and Chef Automate provides that at a glance with the ability to dig in deeper as required. Chef Inspect is a utility for actually scanning our environments and executing compliance defined as code. What Chef Effortless Infrastructure provides are pre-built profiles including profiles based on the Center for Internet Security's benchmarks. And Chef Automate and Chef Inspect have CIS certified profiles for the three major cloud providers, AWS, Microsoft Azure, and Google Compute. Finally, you have Chef Infra, which is how we would remediate issues uncovered with Chef Inspect. Chef Infra allows us both to manage traditional infrastructure and VMs, as well as through integrated cookbooks, configure infrastructure and cloud resources themselves. So if we needed to create VPCs, S3 buckets, etc., that can be accomplished with Chef Infra. In scenarios, though, where Infra or Inspect is not the appropriate tool to use directly, say provisioning environments or creating images, which are not directly their purview, we can assist by integrating with other software that might manage that. For example, we integrate with tools provided by HashiCorp, Terraform, and Packer, so that when you are provisioning environments or creating OS images, you can define how those should be configured with Chef Infra. So ultimately, when you're running Chef Effortless Infrastructure, you have access to Chef Automate. Here we see a high-level view of that dashboard we talked about earlier. And here, what we're able to see is a high-level overview of my compliance posture. I can see exactly how many controls are failing and have them broken down by their severity, and ultimately aggregate all of my insights in one place. No matter who you are in an organization, you should be able to at least see that high-level audit posture at a glance so that you know how much work needs to be done to bring yourself into alignment. Now, if you're in charge of securing those environments or building them out, you can dig into the details where each of these failures becomes an actionable insight that can be used to drive remediation. So in the rest of this presentation, we're going to take a look at a few examples that are largely coming out of those AWS benchmarks that the Center for Internet Security provides. And we can see how we can map those benchmarks to our cloud threats so that we have functional and specific audit requirements that we can use to evaluate the systems we manage. We'll also get a taste of how the Chef Effortless Infrastructure Suite provides us with insights into that estate.
There's a question here.
Oh, yeah.
There's a question before you go in. There's a question here that I think is pertinent. Although you're giving some AWS examples, one question comes in. And if you have other questions, audience, please put them in the question tab. But does the same apply on Microsoft Platform as a Service?
Yeah, so at the very least, when we're talking about the cloud platforms, we have coverage across Azure and Google Compute as well. That includes the CIS benchmarks, which allow us to evaluate the kind of holistic estate itself, make sure that our access policies are set up right, security groups are hardened, et cetera, as well as evaluation of the things that we're running in those providers. So say OS-specific security benchmarks for whatever Windows, Linux, et cetera, servers you're running. Beyond that, we have sort of partnerships and integrations with each of the providers individually. So for folks that have Microsoft accounts, I know that the Microsoft, or the Azure shell rather, has a lot of our tools built into them. So you can use things like Chef Inspect as part of the Azure shell without having to install anything by hand. And both AWS and Azure provide an implementation of Chef Automate that can be run on demand within their clouds. So we integrate on a lot of axes, but for sort of the subject matter we're covering here and being able to evaluate the security of our cloud configurations, we have those CIS benchmarks for all three. Thanks, Alan. Yeah, no sweat. So yeah, let's take a look at some concrete examples. And since we spent a lot of time up top talking about data breaches and identity management, a great place to start is, well, let's at least make sure that every user that has a console password, so everyone who can log in through the web GUI or via their command line tools, should have multi-factor authentication turned on so that I can ensure the people logging into my accounts are who they say they are. So ultimately, we can tie in this back to a lot of different things. As mentioned, Poor access management means that we have a whole lot of other problems downstream. And ultimately, what we get when we run our scans is a control summary. So what we're seeing in the lower right-hand corner here is what shows up if we want to investigate in Chef Automate rule by rule how we performed. It will show us essentially the same text that we see in our example there, what Rule 1.2 is in the CIS benchmarks, as well as some further insight into what exactly is being looked for and why. And then finally, our audit results. In this scan, we got a failure. So we have users in our account that do not have MFA turned on. For the folks that need to manage things more directly, we can also look at the source code of these rules. So again, to perform this continuous compliance, we have a coding language in InSpec that allows us to represent our expectations in an easy to define way. For the folks that actually need to understand what it is that is being checked here, we can see what specifically is being done. We have all users being described where their console password exists, but MFA is not enabled. And ultimately, there should be no users that fit both of those criteria. If there are, we have a failure in this control that becomes our sort of instigator of taking further remediation action. Ultimately, this language is designed to be easy to write for operations professionals, developers, security professionals, and easy to read for anyone who has to come and look at this, so that whether or not you are an InSpec expert, you should at least be able to look at this and see a high level of what is being evaluated. So on top of securing access to the cloud itself, we want to make sure that we harden the resources we deploy within our cloud. We gave an example earlier of making sure security groups are properly configured, especially if you're migrating to this from formal, say, firewall devices or local firewalls and tools like IP tables. Managing security groups might be new for your organization. One of the rules that exists in the CIS benchmarks is to ensure that none of our security groups allow ingress from a universal endpoint to port 22. What this means in functional terms is port 22 is what manages SSH, essentially access to my servers. And I want to make sure that if I'm opening up that access, I'm doing so selectively to sources that I know are my resources. That 0.0.0.0 is essentially a global rule. So we want to make sure we are not allowing global SSH anywhere in our environments. What's important to note about where we can see things in Chef Automate, we can see in the screenshot snippet in the lower right here, where in the region I'm evaluating here, this is US West 2 in one of my AWS accounts, I can see the granular results of my audit. I see here that US West 2 did not pass the audit. That's what the little red triangle tells me. But I can also see in the results a list of all of the security groups that were found and their individual compliance state. So while the region as a whole is failing this audit, I do see that I have a couple of security groups, these first two, that are passing. They are not listening for globally on port 22. But the third one that shows up is insecurely configured. So once again, I have further insight into what specific resource needs to be addressed in order to bring my environment as a whole into compliance. And again, while it's great to be able to scan our cloud resources, even within the cloud, I have traditional infrastructure to worry about. It can take the form of VMs, it can take the form of containers, but ultimately, anywhere that I'm running an operating system, I need to make sure that operating system isn't exposed to any vulnerable system packages, is patched, and is itself securely configured and hardened. Outside of the benchmarks for our cloud providers, the Effortless Infrastructure Suite comes with benchmarks for a variety of operating systems, including Windows, Linux, Mac OS, AIX, and more. For folks that do business in federal worlds, we also have some DISA STIGs available for Windows and Red Hat Linux, which are similar benchmarks that can be used to kickstart your formal validation of compliance standards. And again, This is important because it allows us to aggregate information not only across our cloud providers, but across our entire estate, which for many organizations isn't fully cloud or fully on-prem. Regardless of what systems I'm managing, I can manage them the same way and view their status in an aggregated dashboard with a tool like Chef Automate. So ultimately, what we're driving at here is that by utilizing continuous audits, we have the ability to maintain an up-to-date historical record of our compliance status. So we're not only viewing our compliance status at times that we are audited, but in between audits as well, so that we don't lose insight into how well we're performing and have nasty surprises waiting for us the next time we have to do a scheduled audit. We have an example down below here of a healthcare services provider that Chef has worked with. And before implementing continuous audits, the provider would need to have engineers pulled off of project work in order to write custom data gathering scripts and generate reports. Ultimately, they get provided a list of security requirements in, say, PDFs, spreadsheets. There's not a single standard here. And they need to go ahead and figure out, often as one-off scripts and reports, how to validate those within those environments. This all happened in a one-off fashion to satisfy whatever specific audit request was coming to them. So this had nothing to do with even the problem of demonstrating the historical record, which is just a series of these ad hoc point-in-time evaluations. So now, by being able to codify those requirements into audits that can be run on a regular interval, they've found themselves with a time savings of 95%. By being able to continuously detect and remediate compliance errors. It also means when our auditors come a-calling, we have the data to show them, pick a server, any server, I'll show you its compliance status within my tooling. So another thing that got called out in the CSO article is what they labeled their bonus cloud threat, which were the Spectre and Meltdown vulnerabilities. These were huge, was it late in 2017, early in 2018, when they were identified, and remain a problem for environments that haven't been able to bring themselves into compliance. And there's certainly a trend you can see in various security surveys where when you have organizations that are hit with an exploit of a vulnerability, it's a vulnerability that they've been aware of for months, if not years, just because the process of validating and evaluating the remediation for these problems can be so time-consuming. So this is a great place to call out that above and beyond the profiles and content that comes with the subscription, we also have a huge library of community and partner written content available in the Chef Supermarket. Here we actually have a inspect profile that was created to identify whether a machine is Meltdown, Spectre, vulnerable. There's the word I was looking for. And in the links here, we have a blog post that runs down the issue in more depth. So this is one of the benefits of Chef Inspect, is outside of prepackaged resources, you have the ability to create your own custom security profiles and requirements and codify them alongside the resources that Chef provides. And oftentimes when new vulnerabilities or security issues come about, you'll see content from Chef and Chef's partners providing some insight on how you can address those in your environments without having to wait for the next update from your vulnerability scanners or what have you. As far as where can we go from here? So we have a variety of cloud security resources available for folks. Be sure and check out the Chef Effortless Infrastructure Suite data sheet that should be attached as part of this webinar. And you can go ahead and contact us for a security assessment at chef.io/security assessment. Also, be sure and join us later in the month. I'll be running a similar webinar where we're going to dive in and look at a demonstration of a lot of what we've talked about today. So we'll see Inspect and Chef Automate in action, and we'll even take some remediation efforts so that we can see how we can track our compliance posture over time. And so at this point, I would love to invite the audience to go ahead and ask us any questions that you might have. There is a Q&A widget in the On24 console here. And Alan and I will go ahead and see if we can't address them.
All right. Well, thank you, Nick and Alan. Yep, just feel free to submit any questions you may have that came up over the course of the presentation using the Q&A widget down below. I will start it off with a question here. Question is, can I configure exceptions for CIS controls in Chef Inspec?
Yes. Oh, actually, yeah, of course. So we talked a little bit earlier about this is one of the things that organizations struggle with. So the short answer is yes, absolutely. And the way that works in practice is when you are defining your organization standards, you can actually wrap those standards around any of the pre-existing ones that we have. So say you want to go run the CIS benchmarks. But you can also selectively change what happens when you run those scans, either by selectively not including those controls or rules that don't apply to you, or by changing the severity of them. Each control that's defined in Inspect allows you to define an impact score. And if you wanted to say, treat what is a critical item in CIS as a minor item in your world because you have, say, some compensating controls in place, you could go ahead and wrap the profile, but just change the impact on those associated rules. So you do not need to rewrite any rules to get that customizability.
All right, great. Thanks, Nick. Another one that came in here was that we mentioned a couple of resources based on this topic, but if there's any training options that you think would be applicable.
Yes. So there are lots of training options I'm happy to report. Depending on what you're looking to get done, probably the best place to start is at Learn Chef Rally, learn.chef.io. In Learn Chef, we have a bunch of videos. So if you're not sick of my face and voice, a lot of them I present, as well as a few of my colleagues. And there are also self-guided tutorials for sort of every aspect of our stuff. And one of the follow-on links that we'll be providing is we have a landing page for Learn Chef that specifically collects some of the security resources. So if you just want to get up and running with those security aspects of Chef, we can go ahead and give you the shortcut there. As far as more formal training is concerned, we can accommodate you there. We do regular classes, both sort of public classes that you can sign up for, classes that we run at events like ChefConf, which we run every year, as well as private trainings available. So the full course catalog and contact information for getting that set up also lives in Learn Chef.
All right, great. Another one that came in is that are all of these that you mentioned open source?
So Chef's tools are themselves open source, so Chef Automate, Chef Inspect, Chef Infra. That said, our distribution of those do require a license. So we can provide a link to sort of what the details are there. And if you'd like to learn more, we can get you in touch with our teams to talk about sort of the scope of licensing and pricing for Chef services. The one thing that is worth calling out is the content subscription that was mentioned. Things like the CIS benchmarks and STIG profiles are for customers. So they are not provided as open source content, but are part of a subscription with Chef.
All right, great. I think a follow-on to your discussion of training was just like the experience requirements for the training.
Yeah, and so we have some trainings available for a variety of experience levels, everything from, complete coding neophytes to folks that have some in-depth chef skills and want to level up those skills. Beyond that, we also have a certification process. So we can accommodate trainings for pretty much any skill level, as well as provide resources for getting certified on chef tools, so that you have things that you can look for in hiring or for bulking up your own skill set, as well as having a good indicator of what skills are required.
Awesome. And then lots of questions on follow-up on the training is how often is the content refreshed?
Yeah. Oh, and it sounds like in that one, they're talking about the subscription content like CIS and DISA, and they are refreshed fairly frequently. In fact, I am working on a blog post with some of our folks to talk about, we actually have for STIG, for example, a pipeline that can pull in changes as they are published by DISA. And we have a auto translator that will translate them from their native SCAP format into InSpec. That will go ahead and we verify and promote once it comes through that pipeline. So we are at the point now where we have sort of the ability to fully automate updates to those profiles. And then when you are a Chef customer, you can download them directly from within the Chef Automate UI.
All right, great. Thanks, Nick. Any more questions? Feel free to submit. I'll squeeze in one more maybe here. How would I set up audits of multiple cloud providers?
Yeah, so we have a number of ways to set that up, depending on how they're getting created. If you're just looking to do a one-off audit, like security or ops teams might want to do to just sort of get used to using the tools, we can scan cloud environments via our command line utilities over their respective APIs. So our command line utilities understand AWS, Azure, and GCP as API endpoints. For a more formal analysis, we have the ability inside of Chef Automate to create cloud integrations, where you would put in your sort of cloud access credentials to scan a cloud estate, and then you can create scans directly off of those. In some cases, for example, AWS, we can alternatively pull IAM privileges from your Automate server itself. So if you're deploying Chef Automate into a EC2 instance, say, that has an IAM profile associated with it with sufficient privileges to run scans, you don't need to save your credentials on the Automate server. But you can put credentials from multiple cloud providers there. So even if you're deploying Chef Automate into one cloud or another, you can still scan all of your cloud estates from one place.
All right, great.
Yeah.
Well, looks like we don't have any more questions here, so I will close out the presentation now. Thanks again, Nick and Alan. So for everybody, as a reminder, a copy of today's presentation is located in the resource list widget at the bottom of your screen. We, of course, hope you found value in all the information that was presented today. If you like what you saw, we encourage you to share the presentation with your teammates and professional networks. The on-demand version should be available by tomorrow, and we'll email you as soon as it's ready. You'll be able to access it using the same audience link you're using now. And another reminder again to register for our next webinar with Nick coming up in a few weeks, Cloud Security Assessment for AWS Instances. You can find more information about those and register either on the Chef webinars or the Chef events page. So closing it out now, thanks again, everybody, for your time, and have a wonderful day.